This is for Year 12 methods. It comes out of chapter 9, it's question number 4. It comes out of 9F. It's taking the derivative of this expression. We've actually got two options here. We can use the quotient rule, or I can bring the x to the half to the numerator, multiply out, and just use the differentiation rule. The problem about the latter option is that you then need to factorise. But I'll use both methods and see which one you prefer. So if I was to use the quotient rule, I've got that's equal to u on v, and u in this case is x squared plus 2, so u dash equals 2x, and v equals x to the half, which means v dash equals a half, x to the negative a half. So the derivative, so y dash will equal v u dash minus u v dash on top of v squared. I always start with v. So I'm going to have this one times this one. So I'll write 2x x to the half minus that times that. So a half x to the negative a half times x squared plus 2 all over x, because the square root of x squared gives me x. Now looking for common factors. I have a 2 and I've got a half, so I'm going to take a half out. I've got an x and I don't have an x. I've got an x to the half and x to the negative a half. It's going to take x to the negative a half out. And then that's it. And that's all over x. I took a half out, but I had 2, so I'm going to have 4 in here, because a half times 4 gives me 2. I've got this x remaining, and this x to the half divided by x to the negative a half will also be x. Minus, the half's gone, the x to the negative a half's gone out the front, therefore I'm left with x squared plus 2. And if I was just to work out what this is, I've got 4x squared minus x squared minus 2, which is 3x squared minus 2. So this is going to equal, of the half, the 2 goes down the bottom. This x goes down the bottom to join this x to give x to the 3 on 2. And I've now got 3x squared minus 2, and that's my answer. What would it look like if I had have used some algebra to clean this up? So I could have said that I have x to the negative a half times x squared plus 2. Multiply that out, which will give me x to the 2 minus a half is 3 on 2 plus 2x to the negative a half. And the derivative of that will equal 3 on 2 x to the 3 on 2 minus 1, which is a half, plus 2 times negative a half x to the negative 3 on 2, which equals 3 on 2 x to the half minus, the 2's cancel, x to the minus 3 on 2. And there's my derivative. However, I'd like to factorise it. So what common factors can I take out? I can take out a half. I can take out an x, and since that's a half and that's minus 3 on 2, minus 3 on 2 is the lower of the indices. The half went, that leaves a 3 on the inside. I have x to the half divided by x to the minus 3 on 2. So that's x to the half divided by x to the 3 on 2. Negative, which is x to the half plus 3 on 2, which is x squared. Minus, I took a half out. I didn't have a half there, so that gives me a 2. And x to the minus 3 on 2 went out the front, and that leaves me with 3x squared minus 2 on top, and the 2 goes down the bottom, and the x goes down the bottom, and the negative 3 on 2 becomes 3 on 2, and that's the same as that method. Which method do you use? Well, you use the method that you see to be the most successful, that you're going to be able to do. This is using some algebra to simplify the expression, but then I needed to factorise. This one's using the quotient rule, which enabled me to factorise.